Let's restore them. Write them in a binary format. Decimal not easy to read. First is the IP address. Let's take the example we calculated earlier.
111.0000000.0000001.011011111.
Then I ask a question now. When my subnet mask is arranged like this, how does my mask represent? Okay. 1111111.1111111. 1111111.000000000. Now it is such a form. The above is called IP address. This is called the subnet mask. We first need to write decimal to binary. Afterwards, everyone will observe and you will understand. This is how the device actually identifies. So what does the subnet mask define the network bit and host bit parameters mean? This is very simple. The first step after we convert the binary. The second step, please pay attention. When the subnet mask is 1, corresponding to the network bit. When the subnet mask is 0, corresponding to the host bit. That is to say, we define network bit parameters and host bit parameters. These are called network bits, because it corresponds to 1. The latter is called the host bit, because it corresponds to 0. So, it's actually 24-bit network bits, and is an 8-bit host bit. The subnet mask has its own standard. It is composed of 32-bit binary, left to right. It consists of consecutive 1s and consecutive 0s. Wherever 0 and 1 are connected, 1 and 0 cannot be interspersed. 0101 in the IP address can be interspersed. Subnet masks cannot be interspersed. Must be preceded by 1 and followed by 0. Must be in this form. So now we can determine a network segment. The corresponding network bits are called network segments. I will mark. This part is called the network segment. Everyone will find. When 192.168.1.111. After combining the mask of 255.255.255.0. It can define a network segment. A network segment called 192.168.1.0. That is the preceding digits. Then take it. We can set the latter host location to 0. This is a network segment, and is a mask of 24 bits. Because it's 24-bit network bits, we can write this form. Then what we say? Direct communication on the same network segment. Different network segments cannot communicate directly. It means, when you convert an IP address to binary now, as long as the preceding digits correspond to, no matter how the latter host bits change, both of them can communicate directly. That is, as long as the previous one is the same, are in the same network segment. So no matter how these host digits change, as long as the mask is 0, can communicate directly. But if for two addresses, for example, I now have a 192.168.2.1, such an address is also a 24-bit mask. That is equivalent to a 2.0 network segment. Not in the same network segment as this 1.0. That is to say, this part is actually different. So they can't communicate directly. We can communicate with the help of routing. Can't communicate directly without going through some other behavior. If the network bits are the same, it is the same network segment. If the network bits are different, it is a different network segment. If it is a different network segment, they cannot communicate directly. Let's now summarize what we just said. the address we configured on the device interface. In fact, it is ABC 3 types of addresses. Let's look at the combination of masks and addresses. Different address ranges. That is, Class A, Class B and Class C. Their network range. I've been telling everyone just now. Class A network segment is larger. The network segment of Class C is smaller. Then there are fewer addresses that can be allocated. Okay. Let's fill out a form together. We will divide the addresses into ABC 3 categories. We're going to discuss their network bits together. Host bit. Range of network segments. Number of network segments. And the number of available hosts per network segment. First, let's look at Class A addresses. Class A addresses have 8 network bits. Its host bit is 24-bit. This is a requirement for a Class A address. So you don't need to worry about these digits. The network segment range is 0 to 127. But actually available is 1 to 126. We just write 0 to 127 here. You know it. So how to calculate the number of next network segments? There are now 8 network bits in total. Then you need to see the number of network segments to calculate. Now variable number of network bits. For us now. For example, the current network bit has 8 bits. So now it's 2 to the 8th power. But since the first digit of the entire network segment is now fixed, has a fixed value, the first bit of the A-bit address is fixed to 0. So since the network bits are a total of 8 bits, first fixed, that actually, the range that can be changed is only 7 digits. So the number of network segments is variable network power. It is variable to a total of 7 powers. So now the number of network segments is 2 to the 7th power. But due to the network segment, 0 and 127 cannot be used. So the number of available network segments is only 126. How to calculate the number of available hosts for each network segment? Here's a word. Number of hosts. As the name suggests, it is the variable host bit power of 2. That is 2 to the 24th power. But please pay attention. Subtract 2 here. We have 2 rather special addresses. A network address. A broadcast address. So let's do the calculation first. Minus 2 here. Calculate a value. Yes, 167777214. This is the number of hosts available. Let's look at Class B addresses. Network bits are 16 bits. The host bit is also 16 bits. The network segment range is 128 to 191. The number of network segments is fine. Is a variable network power of 2. A total of 16 network bits. Class B also stipulates the first 2. Then there will be 2 fixed in 16 bits. Actually, only 14 variable network bits. So the number of network segments is only 2 to the 14th power. Don't get confused here. Then the number of hosts available for each network segment is 2 to the 16th power. Because the host bit is now 16 bits. Minus 2. Minus a broadcast and a network address. Finally, calculate the Class C address. Class C network bits are 24 bits. Host bits are 8 bits. The network segment range is 192 to 223. You need to remember this.